you did the reading assignment on it. The reading assignment did not terribly trouble you too much because it was not that hard. It's all stoichiometry. Rather than going through it, I'd like to just do a little review exercise. And I want you to imagine that we have a beaker or flask that has 30 milliliters of 0.2 molar HCl. In the burette above it is 0.1 molar NaOH. We call that the titrant. Whatever's in the the burette is the titrant. I have several different data points that I'm going to ask you to find the pH of. Now, you don't have to find all of them by yourself. We're going to work as a team here. The first row over there, Chuth and back, would you find the pH when 0 ml of sodium hydroxide and 10 ml are added? Okay, collaborate on that and come up with those. Now, when you, and I'm going to assign everybody a couple of points to find. When you get your pHs, plot them. Oops. What do we have here?
I just drew that out.
Oh, jeez.
But they're the exact opposite. They had a concave down and then go concave up.
That's the right graph.
No, it isn't.
KM, Rahi, and Mina, would you do 20 ml and 30 ml of NaOH added? What's the pH at those points? Jennifer and group, would you do 40 ml and 50 ml? And then Michelle and group, would you do 60 and 70 ml? Chanhi and group, you know what? Sorry Chanhi, I'm going to ask you to work with Henry. I'm sorry, you're very gracious to do that. Wesley and girls, would you do 80 and 90? And then you guys, would you do 100 and 110? Thank you.
So we have to measure the 30 ml
You get
of
0.7.
HCl mixed with 20 ml.
We're not even in the same
Right, that's right.
No, because see, when
Dude,
they...
no, like I didn't start yet.
No.
You just told me I'm.
No, we're not in the same. We're not in the same concentration.
Wait, am I
No, guys, when you put 0 molar of NaOH, it's not really...
Hey Elizabeth,
You are
Nothing is happening when you put
you
0
hear my
molar.
voice, right?
0 molar.
Say yes.
So what are we doing?
0 is just negative
That's
log
right.
of 0.2.
Yeah.
You're finding the pH.
0.7.
Dude, I haven't started.
It's just something you put in your calculator. That's it.
60
I'm
ml,
sorry you have to
70
say
ml.
this.
What's our concentration?
20 milliliters and 30 milliliters.
20 and 30.
Yeah, so we just have to do that. So first write down the equation. So HCl plus NaOH is what? So HCl.
Wait, time out.
You don't have to have the H and the Cl.
What are we adding?
Did you have
And
a
then
NaOH
Alright,
and HCl. What do you mean you got this? We gotta work together. Come over here.
What? No, hold on.
I guess this is like Jen Chem review of like I did not learn this.
Oh,
What are we adding it to?
can I look for a second?
Yeah.
Maybe if you come over here, I could tell you.
Okay.
I have like a book.
Wow.
Oh,
This is what I call
I can't see.
So specifically as resonance?
No, like it's like everything. It's like the chapter's called Structures Determines Properties.
Alright,
So
so
then
with
a lot of it was review, but now it's like resonance and then
So it's
H2O,
arrows
right?
of the H.
and chemical
Yeah.
reactions.
And HCl is completely dissolves it.
Okay.
You have 0.2 molar of each.
Yeah, those curved arrows are showing where the electrons are going, right?
Yeah.
0.
It's like the active part of the molecule. That's what they're showing you. It's attacking one of the
And then for the second one, you have to convert it into moles. CO equals 0.7. Find number of moles will be titrated. So you find number of moles.
Done all this, Ellen?
0.0.
Yeah, like the acid base stuff. Yeah. It's just like the resonance and the curve arrow thing.
0.03.
That's not a review of Gen Chem. I know they're not going to do any curved arrows like that.
So then you
Have a quiz this weekend.
10 moles.
Oh, good.
Oh, good. Not gonna be good.
positive log. Right?
Can I help you review it?
I can show you how I do
Point
the
four.
quiz.
Wait, I
Why'd you get
probably
0.4?
did something really wrong.
Oh,
Did you use molarity or the milliliters?
Molarity.
That's how many moles you have.
So you took 0.2 and 0.1?
Well, no, it was, okay, so for 20 milliliters, it's 0.006 moles of H, right?
Yeah, it's pH.
And
Then plot your points.
0.004 moles of OH.
Is this 0.7 or 0.9 per 100 ml?
I think you can just take the M, the capital M.
0 is 0.7.
I think you can just take the capital.
Yeah, but you take the negative log of that pH.
Wait, do we have to
pH is negative log of that. This is what I did during my reading quiz. I messed that up. Forgot to take into polarity.
Yes.
So there's 6.7 points.
Hey, Kate.
There's point. Yeah, 0.9 for 10 of tracks. So you just did 20, 30, and 41. Yeah, and the total volume 0.02.
Is it supposed to be really small, Mr. Bear?
pH?
Yeah.
Yeah.
Okay, like really, really small.
Oh yeah, it's 130.
When you're looking at a scale from 0 to 14, it's pretty small, yeah, like 1 point something.
Oh, never mind.
You're getting like 10 to the negative third or something?
Yeah, I'm getting like point, like I don't know. He just took it. I got like 0.09 or something. I'm probably doing something.
0.09?
Let me see. Hold on.
I get 1.09 for 20.
Okay. You're not supposed to do this.
Calm down, I'm trying to help. You know what? Never mind.
Alright. Is this what you guys got? This is the first one's for 20, so first one's for...
Did you go for 20?
Yeah, that's what we got.
Wait,
0.02, is that what you got? 0.002?
No.
What did you get?
No, look, I got 1.0969, and then for 30 I got 1.301.
1.3 for
Okay, put him up there.
Is that what you guys got? 'Cause that could be wrong.
Ah! That's the right answer!
Go for it. Just go for it.
You're supposed to get. Oh, I did. Oh, for what?
Who's in my row?
So wait, you want to write it out? The equation?
Flying solo on this right here.
Alright.
And then 1 mole of NaOH, because...
1 mole?
wait, not 1 mole. 2 moles.
No, it's 0.1 times 0.2. It's not 0.2, dude. It's 0.0.
2 times... 2.
With 2 moles? It's 0.02.
I assumed that she would get really bored.
That's way too high.
20 times 12.
That's like 12.7. No, molarity times
No, I don't
volume,
want any more.
right, equals moles. Molarity times
Who
volume
is it,
equals moles,
Elizabeth?
right?
Stop, this
It's
is
not
weird.
20
You're zooming in, aren't you?
Right? So
Stop it.
milliliters are 0.002 liters. That's like 12.5. They're arguing over this point.
See, we gotta put our plots too.
John, he's got the height though. I think he can line up as well as anybody.
Wait, Mr. Moore, how's it concave up?
Wesley.
No, these are concave down. No. No,
Goes like this.
Our points are going, Wesley.
They said it was concave down.
First part's concave up, second part's concave.
Right, they did the exact opposite. Yeah, I'm rude.
I don't know what you're talking about.
Exactly, look at that.
I never do it.
Wesley, that's fine. I was right when I did it.
Okay, you know.
Wesley, it's just the point.
Wesley, that's still too high.
It doesn't matter.
Why?
Shani, flat our point.
Hey, Jen.
Hi, was I in the way?
I mean, you
are
can sit
kidding,
down.
right? What?
I just wanted to
With
read
no
the
grid
shot.
lines, you can't. That doesn't help.
Exploiting ourselves.
Alright, I got that.
Alright, now let's figure out what this
Shame
That's
myself
48.
on
We
the
should have the one direction.
Yeah.
I think this helps more than this.
Right.
What?
If I figure it out, are you allowed to tell me?
PK
No.
is infinity.
Huh?
No.
So what?
There's,
He wants to know what it says in the
it's not like, there's no
I
K
told
like.
him I'm like I did my religion. I should tell him.
What's
Do you have a sheet
On
of
that,
scrap paper?
he has a groupie.
See, that's
I can't watch this anymore. Is everybody done? I just got. We have all of our groups in the final points.
One direction.
All right.
H2 plus.
So, what have we done here? We've seen. Nice job, team. Look at how nice that is. And that's almost exactly like what the Zundals had in the book for the graph of the titration curve. Titrating a strong acid with a strong base. It's pretty close. What do we call this point right here? We call that the equivalence point. How do you recognize the equivalence point?
It's pH 7.
All right, now,
For sure.
it does. You see that pH is 7, and yeah, as long as it's a strong,
Sorry.
as long as it's a strong acid with a strong base. it's going to have a pH of 7. We're going to find that when you have a weak acid titration or a weak base titration, that equivalence point is not going to be a 7.
That's annoying.
So just because this one is a 7, don't think, oh, I know the equivalence point is always going to be where the pH is 7. That's not true. You're always going to recognize in general that sharp vertical region, that is the equivalence point. And it may not be that you can identify exactly what the pH is at the equivalence point because, you know, this vertical region, it kind of starts right around there and it ends right around there. So you have to kind of take what the volumes are halfway and then what the pH is, you know, at the midpoint between those two. So we'll talk more about interpreting graphs, but this was very good. I expect nobody has any other questions about strong acid, strong base. Truth?
So the reason the graph takes this shape is because of the negative log function?
Yeah. Well, at the beginning, it's an excess of acid. You've added a little bit of base, but it hasn't neutralized all the acid, so you have an excess of acid.
Right.
Past the equivalence point, now you've got an excess of base. And so the pH is very high. Because of negative log, I guess, yes.
So what defines
What defines the equivalence point? The sharp vertical.
pH is 7?
Is that the definition? It really is because before the equivalence point, we have an excess of the acid. After the equivalence point, there's an excess of base. So in between those two is where you've neutralized all the original acid. So really it is. I mean, as nebulous as that seems, like, that can't really be the definition. That's what it is. Yep. All right. So, and I don't think it's necessary to write this down. If you've been trying to struggle through and write that down and install the other chaos today, I don't know that this is really necessary because it doesn't really give us anything that we need. All titration curves are going to have pH on the y-axis and volume. I'm using the word titrant. Titrant is whatever is in the burette. If you have a case of titrating a weak acid with a strong base or a weak base with a strong acid, the burette is always going to contain the strong thing. So if you're titrating like a weak acid with a strong base, the strong base is going to be in the burette. Because that's the titrant, and that's what we pick up regular intervals of that and see what the pH does.
So there's always one strong.
Yeah, we're never going to do a weak titration.
Do you not want us to write this one?
Yeah, I don't want you to write it down. Have you started already?
No.
Yeah, I don't think it doesn't really tell us anything. Yeah.
Would a weak titration have some like pattern to the graph itself? Because the OH would want to grab the H's off, right?
Man, there's every point there's going to be two different equilibrium reactions
Right.
going on. I haven't dealt with.
Would it go
weak
like?
titration.
Would it be the exact same?
Yes,
like
yes, it
above?
would. We're moving on.
Oh, okay.
Do you want us to write this down?
You're never going to deal with a weak. No, because this is all strong. This is what I just had you do. Originally, I had made out this presentation, say, okay, we're going to take every point as a class step by step. But then after that, now that we did the reading assignment. So, I don't know if you would want to write this down. This is really what you want to take away from it. If you have a strong titration, the pH of the equivalent point is 7. That probably is worth writing down because you're going to have to be interpreting graphs of titrations as we move on. Yes, sir.
Do you do anything but strong?
Yeah, we do weak and strong, but never weak with weak. Like, I'm never going to have you put ammonia weak base in with HNO2 or something like that.
Do we do the same thing for strong?
Yeah, we do, but the calculations are more involved because you got equilibrium that's going on, because they're weak acids. We good with that? Okay, now we're going to move on to titrating a weak acid with a strong base. I warned you, this is tedious. Don't have big lunches for this chapter, okay? You'll fall asleep. So we're going to go through the same exact process as what we did over here. We're going to go every 10 ml, starting at 0. and find the pH. It's just the calculations have more steps to them. So let's see.